cool. So in the physics exam from 2018 senior certificate exams, so I'm guessing this is like final paper, December 2018. So for science,
That one is just NSC.
oh okay, so ASC is something else. So what, ASC is something else? Because DBE just means Department of Basic Education. Science paper. So anyway, we have a science paper. It's paper 2. And it's for 100, how many marks? 150 marks, 3 hours. 150 marks. 150 marks. Max 3 hours. So yeah, we're gonna look at the questions that have to do with organic chemistry, and then we'll refer to the answer provided in the marking guide as well as what we learned from the textbook. Alright, so an example of a saturated organic compound is for 1A. A is ethine, ethine. B, propene. C, butene, or D, 2-chloropropane. So which one do you think is the correct answer from there? And I think we'll have to visit our theory on what are alkanes, alkynes, alkenes, what are saturated, what are unsaturated. So the question is looking for a saturated organic compound, and we have these 4 options. Okay, so a saturated compound has no double or triple bonds, right?
So propene is out. Ethine is also out.
So no double or triple bonds. Okay, cool. So what's out?
Propene and ethine.
So A and B are out. We've eliminated those. So now we're left with butene and 2-chloropropane.
Butene is also out.
Why?
Because it has double bonds. It's an alkene. Alkenes have double bonds.
Alkenes have double bonds.
So it's unsaturated.
Okay. So C has got a double bond. And how do we see that it's got a double bond?
The suffix.
The suffix. Okay. Cool.
But
So alkenes are not saturated.
Unsaturated compound.
Alright, cool. So D is the correct answer, right?
I guess so, because it's the only option we're left with.
Yeah, because we've eliminated the other ones.
Let's see.
And then 1.2. Oh,
Alkanes are saturated.
alkanes are saturated. Okay,
And
cool.
I don't see any other. Because alcohol.
So alkanes, can we say that alkanes are the only saturated?
You can't rule it out, you just do it.
So alkanes are saturated.
Acids are out as well. Ketones are out. Aldehydes are out. Alcohol doesn't have any like double bond thing.
It's got hydroxyl group. Usually those can be bonded with a double bond. That OH.
That's only two form an ester.
Oh, the OH has a double bond when it forms the ester.
I believe so, yeah.
Okay, with hydrogen gas in the presence of a catalyst, what is the product? Is it ethane, ethine, ethanol, or ethanol? I don't think ethanol exists. Maybe. Okay, that's fine. Ethanol. Clear reaction is so ethene, the alkene ethene, it reacts with hydrogen gas in the presence of a catalyst or something else. Yeah, you know what catalysis means? Catalyze.
Yeah, it's to speed up
To
the
speed up,
process
yeah.
of something. I mean, by adding, subtracting. Normally, when you see H2O,
It's just hydrogen
it's
gas,
just
H2.
I don't know. Let's guess it. Let's guess.
Okay. So, looking for reaction with alkenes, right? Alright, so alkenes have double bonds, so we'll have to look at the theory for alkenes. Alright, the alkenes, there must be at least one double bond between two carbon atoms. This means that they are unsaturated and more reactive than the alkenes. The simplest alkene is ethene, and it's also known as ethylene, which can be shown as follows. Okay, so CH2, CH2. What's that?
Well, it's for like alkanes, hydrogenation. When you're adding a hydrogen.
Okay. Oh, by the way, where you can find alkenes, you know this thing where you have a ripe apple and you have unripe apples. So if you put the ripe apple with the unripe apples, it helps speed the unripe ones to ripen quick. So that's alkenes at work.
Really?
Yeah.
So does it also work with mangoes?
I think all fruits.
I mean, they can look avocado barrel.
Oh, I think it works across. I think it works across fruits and food stuff.
Because remember when I read it, that rotten potato.
Theory, yeah.
Rotten potato, like if you have one rotten potato,
It makes the bag.
it makes the bag.
Yeah.
Then as well as
That's
all of
alkenes.
them. Have you ever put avocado inside?
No, I don't know that.
Like when you do that, it like makes it rapid quickly.
I'm afraid of forgetting the apple in there so long that it ends up making the whole baby go bad.
It won't make the cookie go bad. I put the avocado is like covered with syrup. You can put it like in like plastic or something and put it inside inside the cookie. So like you don't have problems when eating up and find yourself having some avocado. Yeah.
I suppose. But anyway, I just wanted us to look for, okay, cool. So ethene is a compound used in plants to stimulate the ripening of fruits and the opening of flowers. Propene is a compound used in the petrochemicals industry to make polypropylene and is used as a fuel gas for other industrial processes.
And then the catalyst for hydrogenation. I don't know, is it lithium or nickel?
Nickel.
Yeah, and then it's Ni, PT, and PD. I'm not sure.
Okay, but the important thing is to know what happens. So what we do know is that ethenes are a bit more reactive than, alkenes are a bit more reactive than alkanes.
Mm-hmm.
And alkynes are more reactive than alkenes, and even more reactive than alkanes because of the triple bond, right? I'm willing to guess that for a reaction, yeah, ethene and hydrogen gas, we will get ethane. Because hydrogen gas is just H2, doesn't have any oxygen to it.
Yeah,
So chances are it might break the double bond, and then we have.
Yeah, because during hydrogenation,
Mm-hmm.
hydrogenation is an addition of hydrogen to an alkene in order to form an alkane. So remember when you have like pentene, you're gonna get pentane.
Yes.
Butane. If you have butene, you're gonna get butane, and so on and so on.
Alright, so the correct answer is A. Yeah. Great. Study the structural formula of the functional group below. So 1.3. It's cool. No, it's cool. It's ok. Alright, so the structure is C, 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 double bonded to oxygen, single, 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 single. And the structure above is a functional group of where we have 3 carbons and 1 oxygen.
Looks like a ketone.
Like a ketone. Let's see.
With this R stands for like
The repeating chains. I remember these R's. Where the R is like the carbon with 4 valent bonds. Okay, so this is ketone. So ketones are C with R there and R there, and then double bonded to oxygen like that, right? So this is what ketones look like.
It's a ketone.
Alright, got it. So that means 1.3 would be B, which is indeed ketones. 1.4. Oh yeah, we are definitely winning with this one.
That's for
Energies, inorganic chemicals. And I think for multiple choice, we are done. We're done. Alright, and then here we have to. Alright, cool. So next to each letter A, F in the table below.
A to F.
Yeah. In the table below. Okay, so question 2. Is as follows. A is C2H5Br. B is C2H4. C is C4H10. D is C2H6O. E is C3H6O. And F
So sharp. It's alright or something.
I'm sharp. Why do you ask? Okay, thanks.
H.
It's C3H6 and O2.
H.
I can't write when I'm laughing. Oh my word, that's so sad. I can't write when I'm laughing.
She said H.
I just remember that. And I was like, oh man, that was so funny. So we have our table. We have our table. Alright. So we've got these chemical formulas. We must first 2.1 choose a molecular formula above that represents an organic compound below. Write down only the letter A to F next to the question numbers 2.1.1 to 2.1.6. So e.g. or to 2.1.5. So 2.1.1 we just need to write the letter, 2.1.2, 2.1.3, 2.1.4 and 2.1.5. Alright. So we need to express a haloalkane. Which one would that be? What's a halide? The group with chlorine, bromine, iodine. So the haloalkane in this case would be which one?
A.
A, ne? Okay. So the next one, an alcohol, would be which one?
D.
D.
Yeah.
Why?
Because that is the molecular formula
of an alcohol.
Yeah.
Remind us again how do we specify it? How do we write it?
Like that. And then we have a structural formula, we have a molecular formula, and
yes.
Condensed formula.
Okay. That's fine. I'm not saying you're wrong. You're wrong.
I would say, like, what
do I want to find out?
Yes.
I want to find out. I mean, an alcohol is like a hydrocarbon that has the hydroxyl OH, right, on one of the carbons, and that means any one of these three that have an O, oxygen, would be correct.
Yeah.
So how do we eliminate the incorrect two so that we get the correct one?
Yeah.
Because D has one oxygen, just as C also has one oxygen.
The number of hydrogens correspond to the number of
Oxygen. Carbons.
The number of hydrogens correspond to the number of carbons.
That's for an alcohol.
That's for an alcohol.
Okay, and how do they correspond?
Like, say, we're gonna have.
Yeah, so
I usually say we're gonna have like C, maybe oxygen, and then we have C, right? And then on, like in a C, the carbon must have like four bonds.
Yeah.
So then I have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's 6 hydrogen. And then
So in other words, for an alcohol,
you have to identify the structural formula.
so an alcohol is whatever the value of C is, the hydrogen correspond by twice. Plus one.
But I usually say we have 2.
Two carbons, yes.
And then we have like, which means is like, how much? 4 plus 2.
4 plus 2 is 6.
We have 6 carbons. We have 6 hydrogens here.
So then it's 2 times the number of carbons
Plus
plus 2. Okay, so 2n plus 2. And then an oxygen. Alright, so that means D is correct by that definition. I'm asking you so that we also test how far you are with being comfortable answering from the perspective of okay, but now I know an alcohol has oxygen and hydroxyl and whatever, but how do we identify from those? Yeah, so I'm asking you those to test that. Now, which one would be an unsaturated hydrocarbon?
Yeah, it can be one of all.
One of all.
Because
Saturated.
And unsaturated, so far we know that it's an aldehyde, a ketone, carboxylic acid, alkene, alkane, and alkenes. So it's like one whole.
Okay, cool. But now I think we're looking for an unsaturated hydrocarbon. That's for alcohols.
Yes, for alcohols and water, it's CnH2n plus 1.
Wait, it's CnH2n plus 1.
So we're going to have 5 carbons. I mean, not 5 hydrogens. And then the OH is going to come with an extra H. That makes them 6.
6 hydrogens, yes.
We're not really far off, but that's not
But that's not the general formula that we know down. Yes, that's true. Unsaturated.
Remember, Cn2n plus 2 is for alkane.
Okay, the one with the alcohol we've already answered. So maybe the halo
And then
alkyne
we
and the
must find an
alcohol
alkane.
for unsaturated.
I get it for saturated.
For saturated, yes, we must find an alkane. And what's the formula for saturated? I think it's this one here.
No, for alkane,
Yeah, for alkane.
it is Cn.
Yes, so alkanes.
CnH2n plus.
So this is the alcohol.
So it's going to be
So this up here is the alcohol. And then an alkane is Cn2n plus 2. And then alkene
Cn2n,
Cn2n
CnH2n.
H2n.
So this is the only part that we like
In chemistry.
in chemistry.
Why?
Memorizing, because these things are so similar. If you want me to memorize one,
Oh yeah, the memorizing.
yeah, the memorizing of like the general formulas.
I see, I understand. So you are saying that for the unsaturated hydrocarbon,
I think it's C. I mean, no, the answer is not C. I'm saying the alkane is C.
the alkane is
Process.
okay. So we've eliminated the saturated hydrocarbon, right? So C we've eliminated for that one. The haloalkyne we've eliminated for that one. The alcohol T we've eliminated for that. So we're left with C2H4. That looks like it could be an alkene because the number of hydrogens in an alkene is twice the number of carbons.
And then that also corresponds to the general form. Because for the alkene, the cell
Yes, that's what I'm saying.
the number of carbons is 2 times the number of hydrogens.
No, the number of hydrogens is 2 times the number of carbons. That's what I'm saying for it. The formula for an alkene is CnH2n. Okay, so that's an unsaturated hydrocarbon. That's one. Then which other one is an unsaturated hydrocarbon?
I think Mario, can you write more than one answer?
Write down only the letter.
Because like there's some instances where like you have like 2 answers, especially when they give you the such a table. You have 2 answers that are maybe, let's say in like this case you have saturated and unsaturated compounds, organic compounds. Then
I get, but it's just 1 mark, so let's just assume it's 1.
yeah, I was saying like
So for 213, it will be B.
And I think even if you go either E or F, you'd still get an answer. You'd still get it correct.
Okay. Then 2.1.4, an aldehyde. What do we know about aldehydes? Yes. That's the aldehyde. So it's C.
Methanol. The now comes from aldehyde. The first.
Oh, the other one. Methanol.
Ethanol. You said
Ethanol, yeah. Ethanol doesn't exist, but it does. It's an aldehyde.
The formula of an aldehyde is that where R is an organic group. Okay. A hydrogen atom is bonded to a carboxylic group. What are the carboxylic groups?
Carboxylic group is the OH. It's that OH.
The O. So basically
So an aldehyde. So there's obviously one oxygen. Great. These are eliminated. C, we've got C. C doesn't have an oxygen, so we don't. And it looks like C is gonna be involved in answering question 5. So let's not even look at C. So here we're left with F and E for the aldehyde. Alright, cool. Let's look at how an aldehyde looks.
an aldehyde, right?
It's C bonded to a hydrocarbon chain, bonded to another hydrocarbon, and an oxygen. Alright, cool.
Here in the molecular formula, okay, this is an example of the molecular formula, right? There is C2H4O.
So I just want to see something. Let's say R was C. Let's say R was C like this, right? So that would be 1, 2, 3 hydrogens, 4, and then 2 carbons and 1 oxygen. So it'd be 1, 2, 3, 4. So the number of hydrogens would double the number of carbons, and then you'd have 1 oxygen. So that means the aldehyde is E. Yeah. And then lastly, a product of thermal cracking of compound C.
First of all, let's find the definition of
Thermal
what
cracking.
is.
Thermal cracking, not just
Isn't it?
It might have to do with introducing heat
Catalyst.
into the
Cracking is the breaking down of large hydrocarbons into smaller and more useful unsaturated molecules.
Alright, so into smaller, less saturated hydrocarbons. So a product of thermal cracking of compound C.
Okay, then we have thermal cracking uses high temperatures without a catalyst. So the temperature, like a high temperature, is used as a catalyst. Right.
Say that again.
Thermal cracking uses high temperatures without a catalyst.
Okay.
And then those are the reaction conditions for
Can you just get the lights on? It's also getting dark in here. It's getting dark in here. So switch on all the lights. Nah, the lyrics are hard. It's kind of bad.
This sounds like because I also don't know the actual lyrics. So
Oh no, if you knew them, you would understand what I say. I don't want to sing them over. Okay.
yeah, it's cool. You must stay professional. However, But the thermal cracking uses high temperatures without a catalyst. Catalytic cracking uses lower temperatures and pressure and causes a catalyst.
I'm just wondering why I keep switching. It's not supposed to switch right there. Yes.
I don't know, I still think it's like a point of thermal cracking of compound C.
Compound C is a
Okay.
okay, yes. So,
And then high temperature, so 18 Celsius degrees.
then it
then-
comes ethene plus hydrogen.
Mm.
So that means this would be what? It's got 4 carbons, so it's methane, ethane, propane. Propane is 3, right?
Yeah, proper for is
So it's butane. So it's butane. That means it should give us butene and
That's
hydrogen.
hydrogen.
Oh, okay, cool. So butene would be alright, cool. So that means C is not included in answering 2.1.5. So it's eliminated already.
Yeah.
We've already used A, we've already used D, we've already used B, we've already used E. So C, so that means
It's going to be a double bond.
there's going to be a double bond.
It's going to be
So let's say we've got 1, 2, 3, 4. Right, and then we apply heat. Let's say so many degrees Celsius. So we'll get plus H2. So if we have H2 and then we have double bond there, then we have 1, 2, 3, 4 C's and 1, 2, 3, 4, 5, 6, 7, 8 H's.
So here I see they broke it into half.
We broke it into half.
Half.
Oh, okay.
Plus H, the extra. So I think it's
Ethene is how many carbons? 2.
And here we have 4, so it's going to be butene. So we're going to have CH, double bond CH plus H2.
Okay, I'm uncertain about that one. Let's just check the answer. It's question 1. Question 2. Oh, so it is B as well. That's interesting. Because I was looking at it and I'm like, no, but that just means we have. Because if you say they broke it in half, you get what I mean? So it breaks in half, ethene and then something else. Also, so ethene is a product of the thermal cracking of a hydrocarbon.
I still don't understand.
No, it's just that straightforward. It means when you
Because I can say here, they have like a double bond.
yes. So
So
and
this
that's why C2H4 applies, because it's 2 C's double bonded and 4 hydrogens.
Okay.
Get. And that comes from breaking that in half. Remember? And then you get like 2 hydrogen, right? Because remember that looks like 4 10. So you break it in half. Now when you break it in half, it means you're only left with this, right? So after breaking it in half and you're only left with this, what happens when you introduce a double bond here? These two fall off. And then you're just left with 2 C's and 4 H's. So that's why B applies to both. You get it? No. Okay, where is it disappearing?
Because like, the answer, I don't know. Because like, look, like, we have two columns. 4, 6, 2, 4, 6.
Yeah.
Right. Isn't that supposed to be the same with that?
Okay, let's do it on a cleaner. Let's just do the next group. So I want us to do it here. Right? So I agree we initially have C4, right? Which if we heat up, we get C2 H4 plus H2, right? So we should get 2 of these plus 2 H2. That's 8. It should just be 2. It should just be H2 there. This means we had 2.
So when you write it down, that kind of makes sense. Makes sense. Like it kind of answers my question because say it didn't make sense or about C2 H4. Like it just kind of didn't make sense to you or like why. So now that like you put it like that, it kind of makes sense because like now we have 2 of C2 H4.
Yeah, so check this out. When we have a double bond, it means each carbon relinquishes the bond it would have with the hydrogen. And that bond goes on to the other carbon, right? So that explains the 2C2H4. H4, there's 1, 2, 3, 4 hydrogens. And then there's 1, 2, 3, 4 for the first one and the other 4 there. And these 2 give us that other hydrogen. So that's what happens. That's why this ethene could apply in both situations. Alright. So now if compound F C3H6O2 is a carboxylic acid, right? So F is a carboxylic acid. It's a cool, yeah. It's a cool. Yes. Yes, we do. It's okay if you surpass me. It means my mission is accomplished.
Oh, so you wanted to have an influence on me. So I'm like you. Say.
Maybe one day when you tutor, you'll also share the same kinds of jokes.
I said I was going to tutor.
You never know. You never know.
Maybe my kids, yes. I don't want to go to physics.
Why not?
Why should they do physics?
I mean, they'll understand everything else there is to understand about the world. At least the material part of it. Isomers. We're looking for carboxylic acids, right? There we go. Cool. Alright, so we are then asked that if F is a compound for carboxylic acid, so 3C3H6O, I believe, was the correct formula? Or O2.
Why
You must write down the structural formula of a functional isomer of F.
So it kind of makes sense for that to be like a carboxylic acid because there's two oxygens.
Two oxygens, yes.
Like what other compound requires two oxygens other than carboxylic acid?
Alright.
And ketone.
A certain type of ant called formicine ants manufacture and secrete formic acid, which is used to defend themselves against other organisms that might try to eat them. Oh, that's why the Chuchana Dibaba so
They have carboxylic acid.
No, they have a formic acid.
What is a formic acid?
Formic acid is like a acid that some ants secrete so that that's probably that.
So does it work the same way like what's that? What are these other insects?
Like a wasp?
No, there's another insect we call it fire. Right, it secretes this other material, it burns your skin.
It's a defense mechanism, definitely.
And it like burns your skin, and after your skin is burnt, you get like this little steroids. Or kind of swelling.
Or like a actual burn.
Yeah,
Develops
actual
pus.
burn. Yeah, I once ate it and it burnt me.
Like burnt you where?
Oh my lord.
And you live, oh.
Like, I can, you know how babies crawl and literally eat and put everything in the mouth?
Yeah,
So
oh, that's how you.
like, I was like literally roaming around the house and found it up in my mouth and everything.
Oh, that must be painful.
Yeah, I think so.
That must be
I think
painful. For a
so.
baby, I can imagine. Yo. For a baby, I can imagine.
Yeah.
But anyway, let's finish up. So, functional isomer of F, how are we going to define that one? Functional isomer. How do we write the functional isomer?
All I do is structural. I started with the structural formula.
Okay, and how do you write that one?
The extras.
Okay, so we have how many carbons? 3 carbons. And are they in single bonds or double bonds? To the oxygen. And but okay, so then I don't have another one. Okay, cool. Okay, then I have oxygen, then I have what is B? I haven't changed them, but I think I know where the issue might be. So this is the functional isomer. What these?
Write down the structural formula first.
Like that.
Yeah. No,
This one.
that's the molecular formula. The structural formula gets like how it's structured.
Okay, so we should start with the structural formula.
I want to start with the structural formula
And
so
then-
that I can, maybe have a picture of what it's going to be. I don't put like carbons or minutes I'm used to.
Okay, I guess that could work. It could work.
So we're looking for the structural isomer.
Yes. So yes,
Is it a structural isomer or a
functional isomer. So here's what the
So structural isomer has the
Wait.
same molecular
Joy, before we carry on, it's good that you identified that the C, one of the C's does that. But I think what's also important is that the C with the two O's is not on the outside like ours. It's sandwiched by the other C's. So in other words, the correct way would be C O C C, right? And then where we have the O, we also have a double bond.
The O is usually the same thing that we did. Can we have two options? Option 1 and option 2.
Oh, the second one we did is the same thing.
It's the same thing.
Oh, okay. Then in other words, then the other one is 1, 2, 3, 4,
Is
5,
that
6.
is that the functional isomer? Or is it the structural formula?
Which one?
Well, does the question say find the structural formula or
Functional isomer.
So but that's the structural formula. That's how it's structured.
Yeah. I'm just no, I'm not saying ours was incorrect. I'm just saying we have to look at another way of explaining or drawing this that are also correct. So we've got 3 there. There's the good. So we've got that. Ooh. 1, 2, 3, 4, 5, 6. 1, 2, 3. So that means even this one would also be correct.
But any correct arrangement of the correct number of atoms.
Any correct arrangement. Okay, that's great.
So basically as long as you have the cool,
So yeah, any correct arrangement of the correct number of atoms. So it doesn't matter how we draw it, whether it's this way or those two ways in the exam. Okay, that's great. It's great to know. There isn't a this is the only way type thing. That's great to know. It's great to know. Really, really know. An IUPAC name of the functional isomer of F.
What is maybe has a question.
The question paper.
If F is a carboxylic acid, write down the
IUPAC name.
structural formula for that. So that I thought I was writing the structural formula for like this. In my head, I'm telling myself this is the structural formula for this carboxylic acid.
Oh, okay.
But yet at the same time, I still got it right. But it's not okay because
Is that okay because?
because I probably would have gotten it wrong. Say, you know, in my head, I thought they told me, because you said structural formula. I thought the question was, write down the structural formula for compound F.
Oh,
Right.
no, they say if it is a carboxylic acid, yeah.
Yes. So I took this and I was like, I'm writing a structural formula of this in terms of it being a carboxylic acid. I thought it was a carboxylic acid or the
Oh, okay. So So
But it's fine because I got it right. However,
It's
next
fine.
time I'll pay more attention.
okay, I'm glad you noticed that you have to pay more attention
Because I thought you said you changed the question paper, you changed the page, you went to that.
to the other page, to the learning guide, yeah.
And then Kauko order structural formula for C3H6O2.
Oh,
And then Vijamar functional isomer. And now in my head, and then you remember when I said it makes sense for it to be carboxylic acid because it has 2 oxygen atoms.
Yes, because it's got the cool part.
Yes, it got the cool part. And I was like in my head, I thought like, oh, that's cool. So that is like a carboxylic acid.
Acid. Alright. So the IUPAC name, how do we then do that for a functional isomer of F?
Well, first one is just like how we do IUPAC name in general. IUPAC name.
Alright.
So we have an oic acid at the end. For carboxylic acid. So it's probably going to be how many carbon atoms we have? 3. So it's
We've got 3, yes.
carbohanoic acid.
No.
No. And how many? So don't we have? Wait.
How do we perform IUPAC naming of our isomers?
Okay, we don't have that.
We don't? I think we did. Didn't we cover that when we were doing the chapter summary?
But
We should have that.
I'm summarizing it. It just says what is an isomer, like what is chain isomer, positional isomer, functional isomer.
No, that's not what we're looking for, definitely.
Yes. And matter after that, they don't have like naming for isomers as names. That's why I went here.
It's fine. We're gonna find how we're gonna.
Also, do we just ignore the? I think only went through the summary.
Yes, we only went to the summary, but it's fine. Then what is IUPAC naming? International Union of Pure and Applied Chemistry. Ooh, nice.
No. But at the same time, I still won't remember that.
It's fine. So the steps include a good general rule is to start at the end or the suffix and work backwards in the name.
Oic.
So we must recognize first the functional group of the compound. So when we look at our structure, we've got 2 functional groups. We've got a meth part, and we've got an eth part, at least for prefixes. Alright. The longest continuous carbon chain that contains the functional group. So our longest carbon chain is the eth part. And then the number of atoms give us that it's it could be ethene, so it could be ethene because we have a double bond here. Right? The number will determine the prefix, so table 4.6. Alright, so 2 carbon atoms gives us if. 1, 2 gives us if, right? And then the number of carbon atoms in the longest carbon chain, we need to start numbering so that the functional group with the lowest possible number is on the carbon group the lowest possible number. So start with the carbon at the end closest to the functional group. Okay, cool. To the middle. It says methyl ethanoate or ethyl methanoate. And that's because in the first case, the meth part starts there and the ethanoate starts there. And in the first one, the ethyl part starts there with the 2 C's and the methanoate is with the 1 C.
That's an ester.
I suppose.
It is an ester. So, yeah.
Why do you do that? Sorry. Yes. I'm listening.
Can you go back to the memo to review the structure?
Let me review the structure. Okay.
The structure is not the same.
It's not the same. Why do you say that?
The O is between the 2 carbon atoms. And then the H, it's not an OH. Because when it's like this, it's a carboxylic acid. And we must find, because I remember, yes, we must find the functional isomer for this.
Okay.
Because I remember, I remember, I was like, I'm writing the structural formula for this in order to get the functional isomer for this.
Okay.
So
So
I
we
think we
wrote
need
the
to
structural
do
formula.
for the carboxylic acid.
So
and
we
not
must
for
write
not for the functional isomer. Because this functional isomer is a ketone. And we never ketone is ester.
ester.
Yes.
So the functional isomer is an ester.
Yes, it is.
Okay.
So that is why this is not making sense for me. It was not making sense for me.
Oh, okay. So then which one do you think is the correct structural formula to have? That one. Okay.
Yeah, we're like with COO.
Where there's a coup at the end or somewhere. Okay. Okay. Okay.
Right. There we go. Because we're not using the H or I, we're just rearranging the formula.
We are not?
We're just rearranging the structural formula.
Yes.
That's how functional isomers work, right?
Okay.
It's the rearrangement of the structural
formulas.
Or moving
right,
it from like one place or putting it
to
to
the
another
other
place.
one. Okay. That's fine. I just want to hear your understanding of how then do we move forward to getting the IUPAC name for this?
We answered according to esters.
Esters, okay.
Yes.
So then if we do that, for this, how would we then do it? Following this guideline here, recognize the functional group and then determine the suffix.
Or you recognize the first part of that, which
So
is the carboxylic acid.
So this one showed that it's a ester. Okay.
Because what I learned is that you find the name for the carboxylic acid. Then you move to the alcohol.
Okay.
Because an ester is a sum. Can I say sum? Or it is a product of an alcohol and a carboxylic acid together.
Okay.
So find the first part, which is a carboxylic acid, which gives us what? Ethyl.
Okay.
And then the next part, which is only, we only have one carbon for the alcohol.
For the OH, okay.
And then that gives us, this is it. See, I was going to be wrong. I was not wrong for naming the first part propanoic acid, because it is a propanoic acid.
It's a propanoic acid, alright.
However, we have to name it from starting from the carboxylic acid, then moving to alcohol.
I just wanted to understand, I just wanted you to explain the process of moving from carboxylic acid to alcohol into ester.
It's esterification.
Esterification. So what about this indicates that there could have been some esterification? Because you want to get that right if you know any indication of that.
Well, because the structural program moved. Well, they have, okay, you want to know how it moved from.
No, I'm just saying you need to have a consistent way of answering the question. That even if it was a different question altogether, applying a similar type of reasoning will still get us the same type of outcome.
I don't know how to reason it, but like, so you get what I'm talking about, do you?
I want you to make it so that I can understand it and say, oh, okay, this is where Joe's coming from. But without it sounding like you are assuming that I can understand everything that's in your mind.
Because you can't.
Yes.
But like, okay, from what I understand from like functional isomers, because they have like the same molecular formula.
And what's that same molecular formula?
The CN is what?
H.
Yeah, H. Let's say 2.
So that's for which ones?
No, I'm saying functional isomer from the definition. It says functional isomers have the same molecular formula. Like atoms are implemented in different ways to form compounds that belong to different homologous series.
Okay.
And then
So homologous series would be aldehyde, would be alcohol, would be right.
acid. Right.
And then a functional isomer would be if you rearrange where the carbons are placed, and then that would give you
a different homologous series.
Alright, cool.
So then the carboxylic acid has a general formula of CN. Double check. Okay, it doesn't have.
Yes, the general as formula.
Yes, but like for ester, there's no general. I don't see any general formula.
They form alcohols and carboxylous acids in esterification reaction. The name of the ester consists of two parts. The first part is derived from the parent alcohol, and the second part is derived from the carboxylic acid. So the functional isomer of this one here would be, if it's a carboxylic acid, then the functional isomer would have the carboxylic part and the alcohol part. Right. So when we write down the structural formula, we should write then the structural formula bearing in mind the alcohol part and the carboxylic acid part. I think that's important. Then the second thing is when methanol reacts, so that's the methyl part, and that's propanoate. Okay, cool. So in other words, and as far as our ester goes, so we ought to have in the first part 2.2.1. so in 2.2.1, if our formula is C3H6O,
they have the same molecular formula.
This is the molecular formula. Yes, it's fine.
Yeah.
But that means if it's a carboxylic acid, then the structural formula of a functional isomer would be what?
CnH2n plus 1.
One, two, three, four, five, six. Would this work? Because then we'll have the alcohol part would be ethyl, and the methanol part would be methanoate. Or we would have methyl ethanoate. So I think then it's important to know that the definition of a functional isomer, when considering not the definition, but when writing the structural formula of a functional isomer of a carboxylic acid, then we have to always consider the alcohol part and the carboxylic acid part. Alright. But that's in esters, isn't it?
The functional isomer of F is an ester.
So the functional isomer of F is an ester. But how do we know that from the question?
So by the time you identify the functional isomer, you must look at the molecular formula.
Okay.
You start by looking at the molecular formula to actually identify a molecule. This would be the functional isomer of this.
It's fine. Wait, say that again. You're saying, so we have the molecular formula.
Yeah, like the general molecular formula.
This is the general one.
That's not the general.
That's not the general one. Which one's the general one?
General is CN2N
Plus 1. And then Q at the end.
Yeah.
So, okay, so this is for a carboxylic acid. This whole thing or just this part?
This part.
And then
Okay.
with the Q,
Q is just how it's structured. The O. And so now you're making me confuse myself because when you're confused.
no, so this is the general one.
Yes.
So that's why I was asking with the Q or just that alone, because I know I wrote it down somewhere. It's the number of carbons is 3, right? The number of hydrogens would be an odd number. An odd number because the other H which makes the H's even number is in the Q. You get it?
I see.
So in the Q,
I'm gonna ban you from talking.
but hear me out. But in the Q, alright? In the Q, that's where we get the H that makes the H's even numbers. Alright, so that's the general formula.
Yeah, and in esterification,
Okay.
the 2 hydrogens. Alright. You move to 2 format. Because you get
Okay, but now that's why I'm asking. How do we know from the question that this is
I don't
esterification?
know.
So then why are you saying it's esterification?
Because I know that it's esterification.
No, how do you know?
But I don't know how I know.
No, you have to know how you know. No, you have to know how you know.
Let's say.
That's why I keep asking. Where in the question is it hinted that this could be esterification?
So I don't know how to answer it.
No, you must know. You can't make a claim and not back it up. No, that's not how we work.
Because that's how I was taught.
No.
I'm trying to find the answer within the exam guideline.
It's fine, but that's why I'm encouraging you to think about it, so that we don't just make claims, because a claim might work in an exam and you might be lucky, but now when you write the exam and the question is a different one on the same topic and you apply the same reasoning, it might not necessarily work.
Yeah.
You see. So I want us to avoid being in that situation at all costs. So here, I'm beginning to doubt these structural formulas, because if there's a coup, then it must show also in the thing. So if we have 4CCOC, that's probably the best structure for the isomer.
Okay, let's say. The memo, it shows an S. The memo, our answer is an S.
It's fine. Now I'm more interested in knowing
How we got there.
how we can say for any situation we will consistently answer the question and get the correct answer. So I don't mind the answer being an S star. I'm just saying, how do we deduce that it's an S star? What logic framework do we use to deduce that it's an S star? And can we apply that logic in any other case?
Okay.
Do share, I'm listening.
I'm just gonna show you these because it's similar to what we did.
Okay.
That's literally the same thing that we did but for propylene acid.
Okay. So functional isomers, same molecular formulas but different functional groups.
Okay, let's get the formula.
Okay, so functional isomer, what's isomerism? Let's just start there. Because it looks like there could be more than one answer for this type of question. And Busha. Alright, cool. Isomers. It is possible for two organic compounds to have the same molecular formula but a different structural formula. Right. Now look.
Structural formula. That's a structural isomer.
It is structural isomer. Okay, cool. So if we were to count the number of carbon in each compound, we find the same. They both have the same molecular, but they're isomers. Okay, cool. So that's why it is possible then to have more than one correct answer for this problem. Alright, cool. If that is the case, then we just have to make sure that we follow the rules that are general and we apply them appropriately. That's all I'm interested in. Yeah. So isomers are molecules with the same molecular formula, and often, although not always, the same kinds of chemical bonds between atoms, but the atoms are arranged differently. So, like in our drawings, the atoms are arranged differently, so each of these could be an isomer. So what? None of them is incorrect? Okay, interesting.
Because like we can put the general structural formula of an ester anyway.
It's fine. I'm not saying you're incorrect.
No, I'm using this as an example. I'm saying you can put it like, you can put it here at the beginning, at the end, in the middle.
Yes.
You can chain it. You can you chain it?
I'm not sure if you can chain it, but what you're saying is you can place the carbon with other hydrogen that has other hydrogens connected to it. Anywhere in the chain and shift it. It can be the front of the chain or at the back or in the middle, or you can attach it to another carbon and it looks somehow. Okay, I get that. I'm not gonna dispute that. What I'm just saying is, what are the rules for making that happen? And what are the rules for naming things after making that happen? And I think we should just be clear on that one, so that when we know what it is exactly that has to be done, then it doesn't matter what the question is, we just answer.
Sometimes we have the answer for that because
no, that's fine. So, okay. So your name was ethanoid. No, because of the 3 carbons, you called yours propanoic acid.
Yeah, but then it was for the carboxylic acid.
Carboxylic acid.
Yeah.
Okay. So then there's no rule that says if it's a carboxylic acid, then the structural formula will have an alcohol part and an ester part. There's no rule for that. That's cool.
All I know is that, like, generally, what I was told with acid is that just know what a carboxylic acid is a functional isomer for ester. It's an isomer for ester.
Okay.
Okay. Yeah.
Because I get that, and maybe your educator meant well when they suggested that.
Mm-hmm.
They probably had I don't know how much evidence they had to say that that's true.
Mm-hmm.
I don't want to say that they're incorrect because I don't know their method. And I don't want to say they're incorrect because I haven't proven that if they have a method it's incorrect. So I don't want to go to that end. But what I want to say is we'd rather avoid generalizing so that we avoid answering questions in an exam based on our generalizations only to get the answer incorrect. That's what I avoid. That's what I was talking about. Yeah, so
But I think when we're looking for an isomer, we look at different factors.
okay.
Like the structure, the number of atoms, you look at the molecular formula as well. You look at the position of the chain. Because in a chain isomer, you can either extend the chain or you can shorten it, right? But still have the same number of carbon atoms and hydrogen atoms inside of the
Oh, yes.
And then that's like some factors that you look at. You don't just look at, oh no, generally esters and carboxylic acid are
Yes.
yeah. So you look at such factors like molecular formula, structural formula, the number of atoms, number of carbon and hydrogen atoms inside, like the chain, the length of the chain, how short, how long, whether you are shorten it, lengthen it, break it.
It's fine.
Yeah.
And that's okay. There are a number of things you have to check out. Definitely, I don't dispute that. But like again, once more, it's probably better to just know what each of these things mean, what an isomer means, and then also being able to apply the correct rules when giving these things names. But it's fine. So we can move on. Compound B is a monomer used to, it's a monomer, so C2H4. So it's ethene. So it's ethene. And it's used to make pollen. It's used to make pollen. Yeah, so 2.3, rather let me do this. Our formula is C2H4, right? So it's ethene. because we have twice the number of hydrogen atoms, so that means we have a double bond. So it's something like this. Something like that, right?
What's that?
Yeah, and then what's the definition of a polymer? I'm not sure. It's fine, we can check it out. Polymer. Esters. Oh, we've been right. You can see where that's been happening. Alright.
No, because last time I checked, they were on page 4.
Time flies when you're having fun. Says who? The toxic kind.
Yeah.
You see, they're saying methanol is toxic and can cause blindness. Now I must listen to toxic music now. Wait. Why do you say it's toxic? I just don't understand.
Because his music is toxic. Like, he promotes toxicity.
In what sense?
So it's not
For class. That's what you'll tell me after class.
It's relationship-wise, it's toxic.
Yeah. Let's finish class and then you'll tell me about this.
When we change our class, we can get home before you leave.
Okay. I think we can end class here. Okay, but let's just finish this nonsense.
Can I just say, why don't you search what is a
Polymer. Oh yeah.
Why don't you search polymer? No, so it's there. We read it day by the summary.
Summary.
And I remember I even told you, like, hey, something I've never heard this word in my whole entire life. I probably heard it,
I remember. It's just that.
but it wasn't something that we discussed in class last year. So go to the summary and find
So much of organic chemistry is just giving these things names, yeah?
Yeah. There's no roots and tools. They know how to write it. Because you can't write root
Yeah.
without showing the bonds. That's what I said.
One chapter have so many of them, like 6 times. You see, it's not even a chapter, it's like a paragraph.
It is a paragraph. Polymer,
Yo.
polymer,
Anyway, we found what a polymer is. It is polymer. It is a large molecule.
Macromolecules.
Yes, macromolecule made up of. So macromolecule.
Micro small.
Yes, but I said macro. Macromolecule made of repeating units. Okay.
Don't say.
Yeah.
Doesn't look good. I've been waiting for the rain, but not today.
What today? Oh, you asked for it. Now you have it.
I said I was very specific.
About?
I said not on a Saturday. Not on a Wednesday when I have to go to class. I was very specific.
I mean, okay, compound B is a monomer. So what would the IUPAC name of the polymer be? Remember, our monomer is ethene. So what would the IUPAC name of ethene's polymer be? You can check the answer.
So what would be like?
Polyethene.
So
It would
the
be.
people who write physics in Africans.
Yep. Then 2.3.3. A balanced equation for the polymerization reaction. So we have to have polymerization. Polyethene.
Oh, so the answer was right there.
Can you imagine? So what would be your summing of the word polymerization? Huh? How many times does the word polymerization appear in this book though? Jeez. Okay. Okay. So the polymerization reaction, in this case, it will be. So it will be that structure.
Okay, so basically we're like breaking the double bond.
Yes, we're breaking the double bond. So it would be however many times this spans, it would be after breaking the multiple bonds, then you'll have, and this carries on however many times. Alright. So in other words, it would be number of times CH2 double bonded to CH2